My name's Bryan Phelps. I have some pretty exciting stuff to talk to you about today. Set the stage. What I'm going to show you today isn't really production ready. Obviously, it's hard to just get it on the screen, but I think it's a glimpse at a potential new frontier for React. It's still a bumpy road to get there, but I think there's also a lot of opportunity. So let's dive in to totally native React. So quick overview of what I'm going to talk about today. First, why totally native React? What led me down the path of pursuing a totally native React? What does totally native even mean? And how is it different from React Native? I'll talk a little bit about a framework I built called Revery, which is part of the way toward a native React. And I'll talk about some great work that the community's doing that gets us all the way to a totally native React. Lastly, I'll talk about what's next, what's the future of these tools, and where do I see the tool chain with reason going, and also the work that we need to get there. So a little bit about myself. My name's Bryan Phelps. I'm the founder of a startup called Outrun Labs, and I'm very passionate about developer productivity and having fast, productive tools. Previously, I was at Microsoft, and I worked on a variety of apps. I want to share a little bit of my experience with you and how I came to care about a totally native React. So looking back over the past few apps that I built, I worked on a lot of different hybrid apps. Those are HTML and JavaScript apps that we bundled up into native apps for the platform. In 2015, I worked in an app called Power Apps, and this was a TypeScript app. It was built with Knockout and Cordova. And we also shipped a Windows Metro app. I worked on an app called GigJam. And this was also built on a similar stack, HTML and JavaScript. And we started out with Knockout.js, but we finally got to move to React with this. So it was really fun to see that transition of going from Knockout to React. And for this team, we shipped on iOS and Android. And we also shipped on Windows and Mac. So another app I built is called Onivim, and I'm very passionate about text editors and having a fast, productive developer experience. I really like Vim, but I also really like the kind of modern features and modern UI that tools like VS Code and Atom give us. So this kind of combines Vim, but brings in those kind of new school features. And it used React and Redux, it used Electron, and it used an open source project called NeoVim. And this project was what I'd call a mixed success. On one hand, we didn't really meet the goals for the project. We didn't meet our performance goals. But it was interesting because there was a community of people that really liked this hybrid, that this hybrid resonated with. So it was interesting to see kind of the possibilities with that. Now, when I look across the board at all of these projects, they're all very different. They're all team size, level of success, target market. But they're all hybrid apps, and they're all built on a similar technical foundation. And I found they followed a similar pattern of development. You'd start out with these hybrid apps where you'd be kind of in this code-sharing nirvana. You could have a single JavaScript code base, and it would work cross-platform. You could package it up in Cordova. You could package it up in Electron, and it would work everywhere. But as you started to add features, as you started to grow the product and the code complexity, you'd see kind of cracks start to form. Maybe the app would start to take longer to start up. Maybe it would be a little bit slower in your transitions or input latency. And it was like that for this last project. We unfortunately didn't meet that bar for performance that we wanted. So I felt kind of torn because I love working with React and Redux. I love that developer experience. I love that idea of a pure function of state and props. But I also really want to write fast apps. I want something that starts up instantly, that responds instantly to key presses. So, I mean, the truth is that you need to strike the right balance and figure out what's right for your users. Like if your current tech stack is meeting all your goals, performing the way you need it to, then that's fine. But sometimes you need to push the boundary a little bit. So before we go further, I'm going to talk about what I mean by native. So it turns out native is a little bit of an overloaded term. One pivot for it is platform native UI. This means it uses the platform provided UI framework. So on like Mac, that would mean using the Cocoa framework to render buttons. This is in contrast to a custom UI like Flutter, where you have your own logic for drawing widgets and drawing the UI. Another pivot is native code. Does your app compile to machine code? And this would be in contrast to using JavaScript, or a tool that compiles to JavaScript code. And to look at this, they're actually independent of each other. So I have this table here, where at the top, it's native code versus JavaScript code. And on the left, it's platform native UI versus custom UI. And so I think to orient ourselves, it helps to kind of look at some technologies that are out there. So React Native is a very popular tool for building apps that uses JavaScript for the application code, but it uses native UI widgets. So it would go in this top right quadrant. Then there's another technology that's coming up that's really promising called Dart. And Flutter. Flutter uses Dart, which compiles to native code, but it has its own layer for rendering widgets. So it would be in this bottom left category of having a custom UI, but native code. We already have native widgets with React Native, so why care about native code? And there's a simple answer for that. It's performance. And this manifests a couple of ways. I really take for granted all that the JavaScript engines do for us when we hand it over a JavaScript file. You take this big JavaScript file, you send it over to V8 or whatever JavaScript engine, it has to parse it and turn it into an abstract syntax tree. From there, it generates bytecode. I might decide to go even further and optimize it to machine code. I'm not going to go deep into these pieces because there's a lot of great talks on that, but the gist of it is there's a lot going on when you have a JavaScript file and you're parsing it and you're running it. And there is a performance cost here. And your users are paying it every time they run a hybrid JavaScript app. And developers are paying it too, every time we use a tool that's based on JavaScript. And it's not necessarily a trivial cost. Just to start up a node process costs about 200 milliseconds. That might not seem like a lot, but if you chain a bunch of build tools together, all of a sudden your builds take seconds, and then as your JavaScript files get bigger, they take longer and longer until you have a build that takes minutes. So for non-browser, or if you're stuck in the browser, you really can't avoid this cost, but that's why technologies like WebAssembly are so exciting. But for non-browser tools and apps, we could take care of this ahead of time. And that's what compiling to native code does for us. So we basically skip all that step, do it as a pre-process, and hand over machine code to our users. So there's another interesting place where performance comes into play, and this is in tools where you have a native to JavaScript bridge, like React Native. So in React Native, you have one side that is maybe Objective-C or Java that talks to the native platform UI, and it has to communicate to the JavaScript application code. And so see what happens is like you get an event on the native side, it has to go through the serialization layer. You have to turn it into something the JavaScript side can talk about. And it crosses this bridge, it gets deserialized, then it gets put on the JavaScript event loop, which is asynchronous. Then it has to get serialized back over across this bridge, and finally make it over to the render thread. This might not seem like too much, but when you have a high-frequency input, like a gesture, that you're trying to synchronize with the scroll, it can be hard to guarantee that that sequence of events is going to flow through and come back in the same frame. A cool thing the React Native team is doing is actually embedding the JavaScript engine in the native portion. So you can get rid of that asynchronous cost, but you still have to pay the cost of serializing between those two runtimes. And this isn't an issue specific to React Native. It happens anywhere where you have maybe a fast language, a fast performing language you're using as a framework for your app, and then maybe a slower performing language that's faster to develop on. So React Native is one case. You see it in Electron where people make C plugins or C++ plugins to work with Node. You'll see it in game engines, like you'll have a Lua scripting language along with a native core engine. And all of those have to bite this cost of that switch between those two worlds. But what if we had a language that was both fast, performance-wise, and fast to iterate on? Coincidentally, like someone had been thinking about this problem space a bit already. Around the time I was looking at what was next for my code editor, OniVim, I was sort of at a crossroads because I hadn't met the goals I set out for performance, and the performance bar for Vim is pretty high. I wanted an editor that starts up instantly, that was lightning fast, but it was clear to me that without a huge level of investment, I wouldn't be able to get it to where I wanted to with the current tech stack. For bigger orgs, they might not have the same problem. Like VS Code, I think, is a great example of Electron app done right. But it really depends on the ability you're able to invest in that. It was about this time that I met Jordan Walk, who many of you know is a creator of React. And I found out about an exciting project he's working on called Reason. And there were a lot of things that got me excited about Reason. Number one, it has a type system out of the box. It's cross-platform. So you could build an app on Windows, Mac, Linux, and run it on all those platforms. It has a great package manager called Easy. So it's kind of like NPM, but for native code. And having a good package management story is so crucial for development. It has a good continuous integration story. So besides just being able to build software, you want to be able to have something that's maintainable, that you can run tests on, that you can validate changes. And performance is huge. OCaml and Reason are fast, not just in runtime, but also in terms of build, so the developer experience is very fast. And for me, the killer feature is the ability to compile natively. So when you combine that with the performance, we've seen cases where you really get C-level performance, which is amazing for a functional language to be on par with like what you'd think of as a systems language. So there's other cool possibilities for native compilation too. I think for me, I'm passionate about user interfaces, like building a fast application, a fast UI. But we're also seeing like command line tools pop up that are native code. So command line tools that are very quick to start up. There's a project called Fastpack that is like a native code equivalent of Webpack. And I think there's also interesting applications in the cloud too. Like when you think back to that chart, like all that V8 JavaScript engine is doing when you give it a JavaScript file, and then you think that a lot of our cloud services are Node, and you're charged by CPU usage. If we could have a developer experience that was fast and native, but also as friendly as like building an app with Express, I think that could be a powerful way to save server costs. And it isn't a new language. It's based on OCaml, which has a small but thriving community, and a lot of engineering effort has gone into it, both in academia and in industry. It feels like a language that was built from the ground up for a React-style paradigm. Like there's a lot of things you need in a functional language. Like the garbage collector has been optimized for the sort of development you do in a React style. So I was pretty stoked. I thought this would be a perfect fit for V2 of the code editor I'm building. I thought that this technology would help us be able to meet our goals of a fast, performant editor. And so we started prototyping our V2. It started to look more and more like an editor as we went along. But as we were prototyping this, we realized a lot of the primitives we were using were really more general than just a code editor. And that's how this framework called Revery was born. So Revery is an application framework inspired by React, built on Reason, and it compiles to native code. So I'll show you a quick demo of that. Let's hope the display works this time. Cool. So this is the app that we'll be building in our workshop. And the development flow is all like NPM. Use easy install instead of NPM install. And use easy build instead of NPM build. First time you build, it takes a little bit longer because it actually has to build the entire tool chain, but subsequent builds are fast. Then I have a custom script to run the app. So it's a pretty simple app. And the fact that it's native code, I don't think makes me any better at it. But it's cool that you can use these primitives to build an app that's totally native code. So there's no JavaScript. This is compiled to machine code, and it just works. Right. What's interesting, though, is besides compiling to native code, it can also compile to JavaScript. This has some kind of unique possibilities when you have this hybrid together. I'm going to start up another demo. So I have this playground here. And this is the same exact app, except it's running in the browser. And so not only does the Revery app compile to JavaScript, but the entire toolchain compiles to JavaScript too, which lets us do some interesting things. Maybe I'm not happy with the way the bird looks. I want to change this from a Flappy Bird to Stretchy Bird. But I don't know, that makes it, I think it might be a little bit harder. Yeah, I don't really like that. So let's put that back. So it's actually compiling in the browser. The compiler is like running in JavaScript, so there's no service calls. And it's fun to be able to have that experience of being able to edit and see your changes live, especially when you consider that it can also compile to native code. So maybe I want a little bit of a sunset vibe here. It's not bad. But besides that, because the compiler runs in the browser, we can also get some insights about what our code is doing. So I'm just adding an expression here, let a equals 1. And the compiler runs, and it's able to tell me that, hey, I know that a is an integer and that its value is 1. And it can also do some more interesting things too. So I'm going to make an add function. And here it reads that, processes it, and tells me, hey, I know you have an add function that takes an integer and returns a new integer. We can run that. It evaluates on the fly and lets us know that I know this value is an integer of 42. And it might not seem that impressive because we have great tools like Replit and Code Sandbox that do this all for us today. But I think the real potential is that you can also compile these to native code. So you could have a lightweight experience for building an app that performs fast, and that you could imagine we have a button that's like download Windows native app or download Mac native app. So for now, Revery is focused on the desktop, but we'd really like to branch this out to mobile builds too. Then I'm just going to show some quick code snippets. This is a bare minimum Revery app. And just like Nick was showing, like if you squint and don't look too hard, it looks almost like JavaScript. The main difference is like there's these open statements at the top. That's sort of the reason equivalent of import and require. And then there's JSX out of the box. So we start our UI with UI.start, and we pass in that view. So this would be a pretty boring app. You can also create custom components with Revery, and it's similar to the components with Reason React. So we pass in the properties with the tilde, with those named arguments for this custom component. There's a children, there's an offset. And then we can use that component below when we start our UI. We also have hooks for Revery. And this is interesting. It was a lot of work to like figure out how to get it to work with the type system. The implementation we have isn't perfect. It adds boilerplate on top of what you already have with ReactJS. But it does give us some interesting possibilities. When you have a component with hooks, your component actually becomes a function that takes in a hooks object and returns a tuple of a hooks in a view. Every time you use a hook, you pass in that hooks object to the hook, and it's going to return you a new one. And you can actually chain your hooks together like this, passing this hooks object to each hook. So if you follow the flow, you get your hooks object, I pass it into my state hook, it returns me a new hooks, And eventually, I return that final hook along with the JSX. And this seems like a lot of boilerplate, for sure. But the boilerplate actually gives you something with the reason type system. The rules of hooks are actually validated at compile time. So if your code compiles, you know you didn't break any hooks rules. You could certainly have other sorts of logic errors, but you have the safety net that you couldn't fall into the traps of breaking hooks rules, like having things out of order or changing the types of hooks you use. So let's take a look now at the tech stack. We have a core reason OCaml API, and this is what you're developing against if you were building a Revery app. And at the core, there's this piece called brisk reconciler, which is like our React native, or React in native reason. We also have a stack to support our native code application. So this is C and C++ code that lives kind of underneath the reason layer. And we have a few different libraries for like text rendering, like harfbuzz and freetype2. Then we have JavaScript libraries, like JS of OCaml, FontKit.js, and WebGL. And an open area of investigation for us is to switch over to a battle-tested library called Skia. And Skia powers Sublime Text, it powers Chrome, and it powers Flutter. So being able to move to that from our homegrown graphics library would be huge in terms of performance and the sorts of primitives that we're able to render. These are the set of primitives and components we have out of the box. So these core set of primitives look a lot like React Native. Then we have some components built on top of that. Buttons, containers, scroll views, trees. We also have hooks as well. So some basic ones like effect and reducer and state. And with those, you can actually build like something that is a usable desktop app. So we have a tree view, buttons, text input, scroll bar. We have custom rendering for the mini-map on the side. And then we have ligatures that come from our native libraries like harfbuzz. And when you're looking at native code, performance is so important. So I did a benchmark of Electron Quick Start versus Revery Quick Start. And I think benchmarking the minimal framework is important because it lets you know like what's the bare minimum overhead of these tools you're using. So for startup time, Revery was about twice as fast, 290 milliseconds versus 670 milliseconds. Memory usage, it used about half as much for our Hello World app, 26 megabytes versus 51 megabytes. Bundle size was significantly smaller because Electron essentially packages an entire browser. But I think the real payoff that you get is as your app grows in complexity. So I compared the V1 and V2 of our editor, and it was a big difference. Our V1 took about 5 seconds to start up. That's time to launch it and then see text render on the screen. Our V2 took about a tenth of that, a half second. And what's somewhat embarrassing about that is we actually did work in our V1 to optimize it. We did async imports, bundle splitting, minification, IIFE. We did all these things to improve it, but yet we were still stuck at something that was around 5 seconds. And so with Revery, like being able to get that 10x speed boost is huge. So now I got to come clean with something. If we go back to our table of native code versus platform native UI, Revery's in the same spot as Flutter. So it compiles to native code, but it has a custom UI, custom drawing layer for the UI. And that's kind of a trade-off. Revery came from a text editor, which has a lot of custom UI components. So in that case, it's really nice to be able to have a framework that you know renders exactly the same on different platforms. This isn't necessarily the right trade-off for all apps or most apps, but for our particular app, it works. Luckily, though, there's some great work happening in the Reason community that gets us all the way to a totally native story. So let me introduce another Reason ML-powered framework called Brisk. Brisk is another framework built on Reason, has a React-like component model, and I'm showing a picture of their Hacker News example app. It also compiles to native code. Right now, they have a Cocoa backend, and they also have an iOS backend that's a work in progress. And then they're working on Win32 and Linux backends as well. And the team that built Brisk built this core Brisk reconciler library that's like the heart of these totally native React solutions. There's a lot of other cool work happening in the Reason community too in this native space. There's Sweet and Pure, which are Qt bindings for OCaml and ReasonML. There's Reprocessing, which is a 2D graphics library. It's more geared towards games than for UI, but it has a great hot reload story and developer experience. Fluid is another cool project that's going on in the Reason native space. This has a platform native UI with the emphasis on animations. What would happen if we could bake in the animation primitive into the reconciler? So I'm interested to see where that goes. So what's next? Everything I've shown you so far, despite being not production ready, are things that you can go try today. You can go to our GitHub and clone the app and run Flappy Bird. You can also go to our website and go to that JavaScript playground and do the same demo I did. I'd like to show you, though, a little vision of like what these tools could look like. So I'll keep my fingers crossed that it'll come up this time. All right. This is the same exact playground as I had before. Same exact game, and same tool chain. It's Reason in the browser, compiling, and a Revery app. What I think is interesting is we always think about our code really as a static document, like something that's a point in time that we build and then we run. But really, as it's running, it's sort of a living thing, like different code paths are being hit and variables are changing over time. What if we could visualize that? So I'm going to scroll down to our render layer here, and I have this aptly named checkbox, the future. And the future isn't something that's production ready, but it's a vision of what we could do with these tools. So when I have this enabled, it actually injects instrumentation over to some of the variables that are changing. So here you can see the velocity is reported. There's the position above that, and then the time is reported too. If I start playing this game, you can sort of see, like, as I go up towards the top of the screen, the position goes negative. And just being able to visualize and see these values in real time is powerful. But you also notice that green highlight behind the code. That green highlight is showing the code path that's taking. It's real-time code coverage. And this part isn't that interesting for real-time code coverage because it's the render part. It's always being hit. But if we go up to our game logic here, this is the core part of the code that handles sort of the game lifecycle. There's this reducer at the bottom, and there's a few different states to the game. So you can see based on the green highlight that we're in this game over state. If I start playing the game, you can see it switch over to that gameplay state, and then go through to the game over state. If I go up here, I can sometimes see some like interesting insights. If I look at this idle code path right here, which is when the bird's just kind of floating around, chilling, I notice that there's this blip like over above the bottom where I'm doing underscore state. And that's like the catch-all part of the reducer where any sort of action goes in, it's adjusting the state. I can see that I'm ignoring that. Like, maybe that's a bug. Like, do I understand why that's happening? Sometimes just adding that visualization can give you insights into your code that you might not expect. Of course, I can also change things live. Maybe I think he's flying too fast and I want to slow him down. So I can go neo on the time. I have this reducer that adjusts the time. And you can see that reflected both visually in how he's leisurely floating there, and also in the time variable there, how it's just slowly incrementing. But that's maybe a little too chill, so I'll put it back. And here, if I go into the game, you can see every time I click, I can see that flap action being triggered. And these are all built on top of the PPX tools that Nick was talking about. The Reason pipeline gives you this sort of blessed way to adjust the source code as it goes through the compiler. And that opens up the ability to instrument your code and maybe visualize it in ways that you wouldn't be able to before. So I'll go back to the slides. And I think that like trifecta, being able to update your code, see it change live, but then be able to visualize the internal state of the code paths being hit, the variables as they're changing, and then be able to compile that to native code is a really powerful developer experience. That's really what I want to focus on with my startup, is this sort of idea that you shouldn't have to wait on a compiler. You shouldn't have to wait for feedback on the code that you're writing. You should be able to get this instant, real-time visualization of how your system's performing. And games is one aspect, but you can imagine for apps and other tools, it could be useful too. So now that I've showed you kind of like the North Star of where I would like to see things go, I'll talk about some of the things that we need to do to get there and some of the gaps that we have today. So one challenge we have is there's actually kind of a split between the native Reason and Reason React. They actually use two different compiler tool chains, and one is focused on working with ReactJS, and one has this custom native React. And the problem is it makes it hard to reuse the components between the two. It's kind of like how React Native and ReactJS was for a while, where it was hard to consolidate. You could share your business logic between the two apps and reuse your code in both places. So you'd have a business logic layer, then Revery components and Reason React components. And then there's a lot of work we need to do to really get the ecosystem to usable state. A lot of investments needed in our developer experience, our debugger, hot reloading, packaging. Like there's still a bare minimum we need before we can really start to explore sort of these next generation developer experiences. For Revery, we want to integrate Skia and have a high performance graphics layer. We need a lot of work on our docs, a lot of work on our native integrations like accessibility, text input. For Brisk, we need to branch out to Windows and Linux platforms. For mobile, we really need to get a nice story for iOS and Android builds. I think once we have these pieces in place, it could be a viable platform to have a great developer experience for building apps. Most importantly, I think we need to leverage the ingenuity of the React community. What I mean by that is there's so much great work happening in React, like state management, animation, routing. There's so many cool projects happening and so much passion and ingenuity. If we could translate just a little bit of that to native code, we could make some really cool things happen. So I have a lot of people to thank for helping with this. There's a core team of contributors that have helped me on OniVim, Akin, Ryan, and Manuel. The NeoVim team has been really supportive of our editor. Lots of help from the Reason team, lots of Revery contributors. And then the Brisk team has been really helpful too. And they'll be here with me conducting a workshop this Saturday. So I want to say thank you. If you're interested, we have a website up, outrunlabs.com/Revery, where you can try out our live playground and get instructions for how you can start building a totally native app. If the idea of a Vim hybrid, like combined with the modern features of VS Code and Atom, is interesting to you, you can pre-order it at v2.onivim.io. Lastly, feel free to follow me or the project on Twitter. And we're going to have a workshop building a Revery app this Saturday from 1:30 to 5:30 p.m. So if you're interested in trying this out, we'd love to come hack with you. Thank you.